This time we're going to be looking at multivalent metals. If you take the page in your book and get a yellow highlighter out, what I want you to do right now is highlight all the boxes that have only one charge in them. Not necessarily +1, but there's only one option in the box. So I've just done all the alkali metals, the first few of rows 4 and 5 and 6 of the transition metals. I'm going to do molybdenum, ruthenium and rhenium, zinc and gallium, indium, cadmium, silver, and and aluminum. That would appear to be it. Okay, these guys are all monovalent. Okay, now you're going to switch colors and we're going to do blue. And we'll do all of the metals that have more than one charge. You can pause and do this much more neatly than I'm doing it if you like. These are all going to be what we call multivalent, which means they're going to have more than one possible charge. Now get a green highlighter and all the negative ions, which happen to be in gray on here, we're going to color in green. These guys are monovalent anions. And of course we did have, and I somehow managed to erase it, the monovalent, although I didn't write cations, I'm going to now. And then our blue guys are multivalent cations. Most multivalent cations are going to be transition metals, although there are a few, germanium, tin, lead, bismuth, polonium, that are part of what we refer to as the poor metals. And thallium, and did I get him in there? No. They're referred to as the poor metals. So they have multivalent too, just like the transition metals. All right, so what does this mean? Well, if we want to talk about iron sulfide, you'll notice iron could have a +2 charge or it could have a +3 charge. Sulfur has a -2, so if it's iron +2, we write it FeS because that adds up to 0. But iron +3 would not add up to 0. Then we would need to do our algebra problem. If we have a 3+ and a 2-, and we're going to multiply those, that has to add up to 0. What times 3 would give us 6? 2. What times 2 would give us 6? 3. That means we're going to have 2 irons and 3 sulfurs. So I need to know Roman numerals in order to express what charge of iron we're using. And for Roman numerals, it's kind of funny because I remember learning Roman numerals, and I think that's probably because we had clocks or watches that still used Roman numerals. You guys don't even have clocks that have numbers, a lot of you. You just have digital clocks. So we're going to go over Roman numerals. 1 is an I. And I'm putting serifs at the top of the bottom. You don't have to. 2 then is 2 I's. 3 is 3 I's. So you would think, 4 is going to be 4 I's. But it's not. It's IV, because 5s are represented by a V. 6 then is V plus 1, or VI. 7 VII. 8 VIII. Then 9 is 1 less than 10, so we're going to put an I. And 10 we use X, and then 10 would just be X. You're not going to go past 8, but I always like to throw that in there. So, our first example given here, to name him, we've been given the formula iron oxide. We know oxygen is a -2, and we know there are 3, so that's a -6. We have to add up to 0. So 2 times what? -6 equals 0. Well, 2 times 3. So, therefore, that iron must be a +3 charge. So we say he's iron 3 oxide. The next guy, we have cobalt and chloride. Chloride, we can look up here. He's one of our green ones. He has a -1 charge. Cobalt can either be a 2 or a 3. So once again, I'm going to do my little algebra problem. If cobalt, but we know how many chlorides do I have in there? We know we have 2. So what 2, okay, I'm sorry, X minus 2 equals 0. What does X have to be? Well, it has to be 2, right? So his name is cobalt 2 chloride. Manganese oxide is our third guy. Manganese could be a 2, a 3, a 4, or a 7. Oxygen's always -2. So if we do our little algebra problem, we don't know manganese. We know that there's only one oxygen there. We know there's only one manganese there, for that matter. And oxygen is a -2. So what does the charge on manganese have to be? He has to be a +2. So this guy's name is manganese 2 oxide. The Roman numeral indicates the exact positive charge. Now, when you have the names, things are a little different because this is telling us the charge. So we can just write lead 2+. Oxygen, we look up here, we see oxygen has a -2 charge. 2 minus 2 is 0. So if you do the crisscross method and bring those down, you'll get Pb2O2, but we can simplify that. So we just end up with PbO. Chromium, Vi is 6. Iodide, we look up here, is a -1. So what are we going to need? How many iodines will we need in order to make chromium happy? We're going to need a total of 6, right? So he is chromium iodide 6. Copper 1. Sulfur has a -2. So how are we going to write that? Well, if we do our little algebra problem, oops, why did I write 21? What coefficients can we put in there to get 0? Well, if we multiply the 1 by a 2, I'm going to pick a different color so you can see it. 2 times 1, that would tell us that we need 2 coppers and 1 sulfide. and that would be copper 2 sulfide. All right, work through the problems on the back of this page.